All right, so we're going to go ahead and start today by talking about the different parts of a radical. So a radical is like our square root, our cube root. So one of the biggest things we need to know is the index. So that's going to be this b value we have right here. So that b value is called our index. And one of the biggest things to know is if there's no b value, then the index of our radical is just going to be 2, meaning that it's a square root. So we see that all the time. If there's no number written there, then our index is 2, we have a square root. So a is going to be the number on the outside, and that's going to be the number that's being multiplied to our radical, and we call that just our coefficient. And then our last little part is what's inside of our radical. So what's underneath that radical symbol is called a radicand. And of course, the entire thing together is called a radical expression. And that's what we're going to be focusing on during this unit. We're going to be simplifying these first. So in order to figure out if something is in simplest form, then our radicand is going to have no perfect square or perfect cube, depending on what the index of that root is. And it's going to have no variables that have more than the index. So that's going to make sense when we go through some of these examples. So first thing, when we look at number 1, 25 is one of our perfect squares. And if you don't remember your perfect squares, you can actually flip to this previous page. I have them all listed for you, like from 1 to 15, all of our perfect squares. So whenever we have a perfect square underneath our radical, we can just go ahead and get rid of that square root and just take the square root of 25, which would be 5. Now, 2,940 is a way bigger number. So there's multiple ways to do this, and I'll show you both ways. But when it's a really big number, one of the quickest ways to simplify this is to actually look at what is the biggest number, the biggest perfect square that we can divide this number by. So this is kind of trial and error. If we tried 225, which is the biggest one on our list, that wouldn't work. But if we did try 196, that would work. So if we do 2940 divided by 196, that would give us 15. So if we go ahead and split this up where we have the square root of 196, and then we have the square root of 15, the number that's left, because we can multiply 196 and 15 and get back to 2940. But what we did is just save ourselves a lot of time, and the square root of 196 is 14, and the square root of 15, we can't pull any perfect squares out of that, so we just leave it just like that. So that would be our final answer for that. So I'm going to show you, this is probably how you learned it in Algebra 1. This is completely acceptable if this is how it makes sense to you. So we have a square root here again. So I'm just going to put this little 2 there to remind us that we have a square root. So what we're going to do is we're going to go ahead and break down 72 by any prime numbers that we can think of. So prime numbers are any numbers that can only be divided by itself and divided by 1. So that would be like 2, 3, 5, 7, anything like that. So we're going to go ahead and just divide 72 by 2. So 72 divided by 2 is going to give us 36. So we have 2 and we have 36. So now I'm going to go ahead and divide 36 by 2 also. So 36 divided by 2 is 18. We can still keep going with this dividing by 2. We can divide 18 by 2, and we can get 9. But we can't divide 9 by 2. So the next highest prime number that we can divide by is 3. Oops. So if we do 3, struggling. If we do 3, then 9 divided by 3 is 3. So those are both prime numbers. So when we have a square root, we're looking to see if we have groups of 2 of the same number. So this, we have 2 2's right here, and we have 2 3's. So when we have that, that means that we can pull those outside of our square root. We can pull 1 2 out and 1 3 out, and we multiply them together. So then what we do next is we talk about the variables. So we also still have this little 2 left on the inside because it didn't have a pair. So if it's lonely and it doesn't have a partner to come out with, then it has to stay inside. Okay, so variables. So there's a method where we can just go ahead and write out all the variables we have. So x's, we have a 3 here. So we have 3 x's, x times x times x. So we're still looking for those groups of 2. So I'm going to go ahead and circle my groups of 2. So that means we have 1 x on the outside, and we're going to have 1 x left on the inside. Because this group can be taken outside because it has a partner, but this group has to stay inside because it doesn't have anyone to come outside with. So next we're going to do our y's. We have 4 y's. So we have y times y times y times y. So we're going to go ahead and circle our 2 y's, circle our 2 y's. So we have 2 groups of 2. So when you have more than one group, this is where our exponent comes into play. So this is why we would have y squared, because we have one group and we have 2 groups. All right, and last we have z. So we're going to go ahead and write out our 5 z's. So we have 1, 2, 3, 4, 5. So we have 2, 4, and then this guy is lonely. It has to stay inside. So we have 1 z on the inside, and we have 2 z's on the outside. I'm running out of room. And we'd have z squared. Okay, so then our final step, when we write our final answer, we just need to go ahead and multiply those two numbers together. So we would have 6x y squared z squared times the square root of 2xz. So as you can see, dividing all of it and getting our prime factorization is going to be a lot more work, but it's going to work every single time. So if that makes more sense to you, then definitely just go ahead with that process. All right, so let's now try, we have a cube root. So when we have a cube root, instead of looking for groups of 2, we're going to look for groups of 3. And we can do the same thing we did before where we look at our perfect cubes. So if we come up here, we have a list of perfect cubes from 1 to 10. We can figure out what the biggest perfect cube is that we can divide 48 by. So if I go ahead, we can try 48 divided by 8. That's going to work. So if I wanted to skip all of the prime factorization, I can go ahead and just rewrite this as the cube root of 8 times the cube root of 48 divided by 8 is 6. So we would still have 6, and we'd have all of those variables left in there. And we'll get to the variables in a minute. Okay, so the cube root of 8 is just going to be 2. And if you notice, all of our variables, when we simplify number 3, we actually went ahead and just divided our exponents by our index. So I'm going to show you what we did there. So if you see that we have a 3 on the outside, back to number 4, and we have x to the 3rd power, if we want to simplify that without writing everything out, we can just go ahead and divide that exponent by 3. So if we divide 3 by 3, we're going to get 1, and we're going to go ahead and have 1x on the outside and none left on the inside because they're all going to go away. Then same thing with our y. So if we were to divide 6 by 3, because our index is 3, 6 divided by 3 is 2. So we're going to have y squared on the outside. okay? And then finally, we're going to have z. So z, we have only two z's, and we can't divide two, or we can't divide 3 into 2 at all. So what that means is that just z squared is just going to have to stay on the inside. So we're going to have z squared on the inside. We only have, and if you want to think about this as writing it out, we only have two z's, so we have no group of 3, so they just all have to stay inside. All right, and then we still have this 6 that can't be done we can't do anything with it because that's just it's not a perfect cube, it doesn't have any perfect cubes, so we're just going to leave it. So that would be our final answer. All right, and so now this last one that we're going to do together, oh, and we talked about what we do with our variables. We divide by our index. Okay, so last one, now we have this 6 on the outside. So that means that we're looking for groups of 6. So when we don't really know our perfect to the 6th power, so we don't have any, like, we have perfect squares, we have perfect cubes, we don't have perfect to the 6th powers that y'all need to memorize. So what we're going to go ahead and do is just break this down like we did for number 3. So let's start by dividing 64 by 2. So we have a 2 here. 64 divided by 2 is 32. And now we're going to break down 32. We can divide by 2 again. We're going to get 2 and 16 because 32 divided by 16, I'm sorry, 32 divided by 2 is 16. And then we're going to go ahead and do the same thing. So we're just going to keep going. So 16 divided by 2 is 8. And 8 divided by 2 is 4. And 4 divided by 2, I'm running out of room, is 2. All right, so we're going to go ahead and circle groups of 6. So we're looking for 6 of the same blue number. So we have 1, 2, 3, 4, 5, 6 twos. So we're going to circle all of those twos. So we're going to pull just 1 2 out because we had 6 twos on the inside. All right, so now we're going to look at our variables. So we have 6 x's on the inside. If we go ahead and just do the breaking it up by dividing our exponents, so if we do 6 divided by 6, then we know that we're just going to have 1 x on the outside. Now, y to the 7th is a little different. So let's think about how many x's, or sorry, how many y's are going to fit, how many times 6 is going to fit into 7. So we know 6 is going to fit into 7 one time. So we can go ahead and make y to the 6th, and then think about it as we have a remainder of 1y. So this can come out where we just have 1y on the outside, but we're going to have 1y that stays on the inside. And when we write our answer, we need to make sure to keep that 6 on the square root. So that index needs to stay there. All right, and then for the last one, we have z. So let's think about how we can write z. So we have 13 z's. So we can write this as z to the 12th because 12 is divisible by 6. And we're just going to have a remainder of 1z left over. So if we go ahead and divide this by 2, then we're going to have z squared on the outside, and then we're going to have 1z left on the inside. All right, so that is going to be our final answer. So go ahead and try these on your own. I would pause the video and try these on your own and check this key on Schoology to make sure you got them all right. All right, next we're going to go into multiplying radical expressions. So there's kind of a few ways to do this. You can either multiply the radicands and then simplify, or you can simplify each individual radical and then multiply. So we're going to go ahead and start with number one. So with our radicals, we can go ahead and multiply. So whatever's being multiplied on the inside can be written as like the product. So where we split it up into two different radicals. So what I like to do is break down each one separately and then write them all together underneath the radical. So 5 square root of 5 is, I'm going to make one long radical where I put all of these numbers. So square root of 5 is, we just have 1 5. We can't break that 5 down anymore because that's just a prime number. But what can we divide 35 by? So since it ends in a 5, I know I can divide it by 5. 5 is a prime number, so I'm going to go ahead and write it there. And then we can divide 35 by, or sorry, 35 divided by 5 is 7. 7 is also a prime number, so that's what we're going to have inside of our square root. So just like we did with simplifying, once you get to this step, it's exactly the same as simplifying. So I'm going to go ahead and circle, I have 2 5s, and we're doing 2's because we have square root. So our index is 2. So I have 2 5s on the inside. That means I can have 1 5 on the outside. And then this 7 has to stay inside because it doesn't have a pair, and it's going to be just square root of 7. So that would be our final answer for that. Now for the next one, we have numbers on the outside. So what we're going to do with those is we're just going to go ahead and multiply those numbers first. So we have a 3 times 4, that's going to be 12. And I'm going to draw my long square root again, and then we're going to do the same thing I did before. So if I do 7 times 8, we might save some time, but not necessarily. So I'm going to go ahead, 7 is a prime number, so I'm going to go ahead and write it under there, under my long radical where they're multiplied together. And then 8, how can we break up 8? So we can divide it by 2. 8 divided by 2 is 4. And then we can divide it by 2 again, and we get 2. So we have 3 2's that we can put inside here. So again, I'm still looking for groups of 2 because we have a square root. So I'm going to go ahead, I have 2 2's here. I'm going to circle those, but this 2 doesn't have a friend, and this 7 doesn't have a friend, so they have to stay inside. So here's where it gets a little bit tricky, not really tricky, just different, but we are pulling 1 2 out. So we're going to do 2 times 12. 2 times 12 is 24, and we're doing that because we're pulling this out and we're timesing it by 2. We're timesing it by whatever number we're pulling out. And then we still have our square root, and we need to multiply our remaining numbers. So we have a 7 and a 2 that we're multiplying together. So 7 times 2 is 14. So this would be our final answer. All right, so moving on to the next one, now we have cube roots. So when we multiply, our indexes should be the same in order to combine them. So we're going to go ahead and do the exact same thing we did before. So this is where you can simplify before if you want to. It's kind of up to you, and I'll show you how that looks. So if we go ahead and break down 54, what can we divide 54 by? That would be a perfect cube. So if we actually divide this, I'm going to go ahead and do it that way. So if we break this up where we have a perfect cube of 27, because we can divide 54 by 27, and we'll have the cube root of 2 left over, because 54 divided by 27 is 2. So this is just going to be, this cube root of 27 is 3, and then we have, I'm just going to draw my long cube root again, we have a 2 left on the inside because of this guy. So we have 2x's here. We can't simplify that within the green square root or cube root, so I'm going to go ahead and just rewrite it. And then we do have 3 y's. So we can go ahead and divide 3 by 3, and we just have 1 y on the outside. All right, so let's go ahead and figure out our red cube root now. So 5 is not a perfect cube. There's nothing we can pull out of it, so I'm just going to go ahead and write times 5. We have three x's. So I'm going to go ahead and pull that out. So 3 divided by 3 is 1. So we have an x on the outside. And then we have 4 y's. So this is where we can break it up. So we can make it a multiple of 3. So we have 3 y's, and then we have 1 that's going to be left over. So this means we're going to pull 1 y out, and we're going to have 1 y on the inside. And then from there, we're just going to go ahead and multiply everything that we have. So mostly just multiplying this 2 and this 5 to make it look a little cleaner. So we have 3 and, oh, sorry, I missed that, but we have 2 y's on the outside. So that means we're going to have y squared on the outside. And we have an x. And then we have cube root of 2 times 5 is 10. We have x squared times y. Okay, so we're going to do 2 more examples, and then y'all are free to work on your own things. So we still are going to be doing the same exact process. We have numbers on the outside that we're going to multiply first. So we have a 4 and a 5. So I'm going to do 4 times 5, which gives me 20. And now, so there's not really much to simplify, so I'm going to go ahead and use the same process that we did before, where we just write everything under the same radical. So I'm going to draw my long square root. I'm actually going to go ahead and move this up so I have room to write my final answer. So we have 20. And we're going to draw our long square root. And we have a 2 from the first radical. So I'm going to make that our green radical. We have a 2 and we have an x. So I'm just going to go ahead and write those there. So in our other radical, I'm going to break down 6, so we can break that down a little bit. So 6 divided by 2 is 3. So I'm going to go ahead and write 2 and write 3. So there's no pairs within those numbers, but we might have something in our long radical that we can simplify. So then we have an x, just one x. And we have 2 y's. So I'm going to write out my 2 y's. All right, so looking at what we have inside, we're going to go ahead and look for our pairs. So we have 2 2's. So we can pull out 1 2, and we can multiply it to that number on the outside. So we're going to pull 1 2 out and multiply it to 20. So we're going to have 40. All right, so we also have 2 x's. So that means that we're going to pull 1 x out, and we're going to have 1 on the outside. We also have 2 y's. So we're going to go ahead and pull just 1 y out because we have a pair on the inside. And then lastly, whatever we don't have taken out, we're just going to leave inside. So we just have a 3. So that 3 is going to stay on the inside. So this would be our final answer. So again, it's kind of however you want to process it. If you want to simplify first, go for it. If you want to multiply them first and then simplify, it's up to you. So we're going to do one more and then y'all are free. So we're going to go ahead and multiply our numbers on the outside first again. So we have a negative, remember that's the same thing as a -1 times 2. So we're going to have -2 on the outside. So I'm going to go ahead and simplify first this time, I think, and then we're going to see what that means for us. So if that saves us any time, it may not, which would be annoying, but it's okay. We're still doing the same amount of work. So we have a 2 here, we have x squared, and we have y squared if we're looking at our first radical, and we have a 3 on the outside this time. So let's make sure we write that 3. So 2, we have x squared, and we have y squared. None of those can come out, so we have to leave them there. There's no simplifying we can do right away. So our green one, we're going to go ahead and break down 16. So I'm going to divide it by 2. That gives me 8. I'm going to go ahead and divide that 8 by 2 also. That gives me 4. And I'm going to divide 4 by 2, and that gives me 2 2's. So this is where we can kind of simplify as we go. We have oops, sorry, we're looking for pairs of three, groups of three because we have that cube root. So we have one group of twos that's going to come to the outside. So we're going to multiply it by 2 on the outside. And we have 1, 2 that's left on the inside. So I'm going to write that there. All right, and then we have 5x's. So I'm going to write this as a multiple of 3. So we know we have a 3 within there. And if we go ahead and do 5 minus 3, we have a remainder of 2. So we're going to have 1x on the outside because of this. And then we're still going to have x squared left on the inside from our green radical. And then lastly, we're going to have a y. So we have one y. We can't do anything with that to simplify. So we're just going to go ahead and put it inside of our long radical. So this is where now we're looking for pairs within our long radical or groups of 3. So on the outside, let's go ahead and simplify that. We have negative 4x out there right now. So on the inside here, we have 4 x's. So we can write that, I'm just going to draw it over here. We can write that as x to the third times x. So we can pull out one more x, and since we have one already out there and we're adding another one, we can just make that x squared. So those x's are out of there. Now let's look at this. We have this right here. We have 2 y's and then we have one more. So we have 3. So since we have 3 and we're looking for groups of 3, we can just go ahead and pull one y out. And the only thing left inside is going to be this extra x right here. And then we have 2 times 2. So I'm going to go ahead and draw my cube root. We have 2 times 2, which is 4. And then we have just one x left over. And that would be your final answer. All right, so y'all can go ahead and try the next 3. And that's going to be it for today's topic. So